So I don't remember what year this one was from, but we've got a particle that's moving in the xy plane. Its position is x of t, y of t, and it gives us the velocity vector cosine t squared comma e to the 1/2 t. And we're also given an initial position of the particle. Well, not an initial position, but we're given a position at t equals 1 that it's at 3, 5. So first thing it wants us to do is find the x coordinate of the position of the particle at t equals 2. So in order to figure out the x coordinate, we need to figure out how far it moves between 1 and 2, and then we need to add its initial position to that. So the value for x of 2 ought to be its initial x position at t equals 1, plus how far it displaces from 1 to 2 in the x direction. So it ought to just be 3 plus the integral from 1 to 2 of cosine t squared. Remembering that the integral of your velocity vector tells you how much it displaces, right? Not the actual distance that it travels. And that came out to be 2.557. Easy enough there for part A. Part A should have been really, really straightforward. Hopefully you did not forget the initial condition there. T equals 1 is at 3, 5. You got 1 point for having the right integral, 1 point for using the initial condition, and 1 point for the final answer. So that's actually worth 3 points for that minimal amount of work. Everybody good there with part A? All right, part B. So for part B, we're talking now only between 0 and 1 non-inclusive. There's a point on the curve where the line tangent to the curve has a slope of 2. So we want to know what time is the object at that point. So to find out the slope of the tangent line to a position vector, we need to find the value of dy dx, which should be dy dt over dx dt, which we should know. So we just need to find e to the 1/2 t over cosine of t squared. And there's my dy dt, there's my dx dt, since those are the velocity vector, those are the derivatives of the position vector. And we just need to set that equal to 2. And once again, since this is a calculator problem, just plug in this function, plug in y equals 2, calculate the points of intersection, or subtract 2 and find the x-intercepts, and you should end up with t is 0.840. And hopefully that one was pretty easy as well. Everybody good with that one? It was 1 point for having the right value for dy dx in terms of t, and then 1 point getting the actual value there. Good or no? All right. Part C, we want to find the time at which the speed of the particle is 3. So the first thing we need to do is figure out what is the speed of this particle. And we know speed is the absolute value of velocity, right? So since speed is absolute value of velocity, absolute value in terms of vectors means the magnitude of the vector. So we are looking for the magnitude of the velocity vector. And all we have to do to find the magnitude of the velocity vector is the square root of the x component squared plus the y component squared. So our x was cosine t squared, right? Squared, and then our y was e to the 1/2 t squared. And we just want to know when is that speed equal to 3. So we'll just set that equal to 3. You can just graph it as is, or if you want to simplify that down to something like cosine squared t squared plus e to the t inside your square root equals 3. That's fine too. And then you just plug that in. You can plug both of them in and see where they intersect, or you can subtract 3 and look for the x-intercept of the new function. Either way, that should give you t is equal to 2.196. And this was, again, 2 points. So 1 for having some sort of speed equation, either this or this would be fine. And then 1 point for setting it equal to 3 and getting the right answer. Any questions there on part C? All right, and we want the total distance then traveled by the particle from t equals 0 to t equals 1. Does the absolute value affect anything? So no, so Ryan, the absolute value, when we talk about the absolute value of a vector, that means the magnitude of the vector. And so the magnitude of the vector is the square root of the x component squared plus the y component squared. That's what the magnitude is. That's what the absolute value of any vector is. Because if you think about a vector, right, we talk about a vector being from the origin to some point. And so if we're talking about the magnitude, that's just the length of that vector. And so that's always the x component squared plus the y component squared, because it's just a right angled triangle there. Does that make sense, right? Cool. All right. Cool. Any other questions on part C? All right. So what was part D again? Okay, find the total distance traveled by the particle. So the total distance that a particle travels, the distance it travels is just like we've always done with regular particle motion. The distance traveled of something is the integral of the speed on the time interval that you're looking at. So we have an expression for the speed down here, which is the square root of cosine squared t squared plus e to the t. So for part D, all we got to do is integrate from 0 to 1 the square root of cosine squared t squared plus e to the t dt. And you get an answer of 1.595 units. And that's also worth 2 points, 1 for the integral and 1 for the answer. Everybody good there? Any questions on that? All right, I feel like that one was a really doable one. That one should have been pretty straightforward. All right. Next one here. So now we've got a particle moving along some curve in the xy plane. We have its position. We got a position vector here. And we know the values of dx dt and the value of dy dt, and we know the position of the particle at t equals 2 be 1, 5. So first thing we want to know is the horizontal movement of the particle to the left or to the right at t equals 2. So all we need to do is figure out whether the value of the derivative of x, or what dx dt is. We want to know if dx dt is positive or negative at t equals 2. So if dx dt is positive, it's moving to the right, and if dx dt is negative, it should be moving to the left. So all we'll do is say dx dt evaluated at t equals 2. And that ought to be the square root of 4, which is 2 over e squared, we see that 2 over e squared is most definitely positive. So we say it's moving to the right because that x component is positive. The dx dt component is positive. Then we want to find the slope of the path of the particle at t equals 2. So in order to find the slope of the path of the particle, that means we need to find dy dx. And so we know that dy dx is dy dt over dx dt. And we just need to evaluate that at 2 equals 2. So dy dt is the sine squared of 2. And then the e to the t will come up to the top and become an e squared over square root of 4, which is 2. And you've got a calculator. Your calculator will tell you what that value is. It looks like it comes out to be 3.055. Everybody good there with part A? Cool. And let's see, what was the breakdown here? Moving to the right with a reason. So dx dt is positive, moving to the right. That's 1 point. 1 point for this and 1 point for this answer. Part B, very similar to what we were looking at, and I think it was part B of the last one. We just want to find the x coordinate of the particle's position at t equals 4. So we need to find the displacement from 2 to 4, and then add to that the initial x component at 2. So for part B, we'll just say that our position at 4 is the initial x component plus the integral from 2 to 4 of our dx dt value, which now I don't remember what it was, dx dt. And we end up getting some value there. What would that value come out to be? 1.253. And that was 2 points, 1 for the right setup with the integral and 1 for the value. Any questions there on part B? All right. Part C, we want to find the speed of the particle at time t equals 4. So very similar to the last one again. Our speed should just be our absolute value of our velocity, which should be our magnitude of our velocity vector here at t equals 4. So that ought to be the square root of, let's see, was it 4? Yeah, 4. So root 6 over e to the 4th. Squared plus sine to the 4th of 4. And that came out to be 0.575. That was 1 point so far. And then the second part of that question was asking about the acceleration, I think. Yeah, find the acceleration vector of the particle at t equals 4. So all we need to do is find the derivative of the x component here of our velocity and the derivative of our y component of our velocity, both evaluated at 4. Since this is a calculator problem, you don't actually have to find the derivatives of each of those by hand. You can just let your calculator do the work for you, but you'd want to at least show something like the derivative with respect to t of dx dt at t equals 4 and then the derivative with respect to t of dy dt evaluated at t equals 4. Something like that. Or you could write x double prime, y double prime of 4. That'd be fine too. That's probably a nicer notation. And you'd get your velocity, or sorry, your acceleration vector, which would give you negative 0.041 and 0.989. And since they're talking specifically about a vector, not just the separate components of it, make sure you put it in the angled brackets there to indicate that it is a vector. And you get 1 point for the right vector. Any questions there on part C? All right, and then what was part D asking us about? We want to find the total distance traveled. So if we're looking for the total distance traveled by the particle from 2 to 4, that should just be the integral of the speed from 2 to 4. So we'll just say the integral from 2 to 4 of our speed equation, which is the derivative of our x, our dx dt, which was, now I forgot what it was. Root t plus 2 over e to the t. Squared, and then plus, I think now it was sine to the 4th of t. Yeah. dt, and that comes out to be 0.651. Everybody okay with that? 1 point for the integral and 1 point for the answer itself. Any questions on that one? Cool. All right, and then we had one more that I had you guys do. Oh, show part B. Yeah, right here. Just let me know when you're good. All right, cool. All right. So next one, this was the last one I think I asked you guys to do last night. Is that right? Okay. So we've now got same thing, right? Just worded slightly differently each time. And we're given a dx dt and a dy dt. We're given a position that's written slightly differently. So these should, I hope, just be pretty straightforward now. So we're finding the speed of the particle at t equals 3. So once again, our speed of our particle ought to be the magnitude of the velocity. And velocity is dx dt dy dt. So it ought to be the square root of 4t plus 1 squared plus sine squared t squared evaluated at t equals 3. And that should have come out to be 13.006. And then to find the acceleration vector, we just needed to take our derivatives here. So our acceleration vector should be 4 for the derivative of 4t plus 1, comma, oh, right, we're evaluating at 3, so just the derivative with respect to t of sine of t squared at t equals 3, whatever that comes out to be, which was negative 5.466. Good or no? One point here, 1 point here. 2 points for that one. Any issues there? All right, now we want to find the slope of the line tangent to the path of particle at t equals 3. So we need to find dy dx. And we've done that a bunch of times already. Dy dx should be dy dt over dx dt. And we just need to evaluate that at t equals 3. So sine of 9 over 13, which comes out to be 0.031. And just 1 point there for that. Everybody good with part B? Okay. Part C. What was it asking us? Finding the position of the particle at t equals 3. So that means we got to find the x component and the y components of that position. So that means we're going to need to do 2 separate definite integrals. We're given positions at 0, so we'll have to do integrals from 0 to 3 of the x component of dx dt, and an integral from 0 to 3 of dy dt, and then add our initial positions to each of those. So our value for x of 3 ought to be its initial position at t equals 0, which was 0, plus the integral from 0 to 3 dx dt. Which came out to be 21. That one you should be able to do without a calculator. And then your y of 3 ought to be the initial position. I think it was -4 for that one. Yeah, -4 plus the integral from 0 to 3 of sine of t squared dt. And that came out to be -3.226. And so just make sure that you write your answer as an ordered pair, because it asks at what point is it at, or something like that. It says find the position. So this is the position. Make sure you write it as an ordered pair. And let's see here. Well, actually, I guess they didn't give a point for the ordered pair. 1 point for the integral, 1 point for the integral, 1 point for that, and 1 point for that. Good or no? This should have a dt attached to it. Any questions there on part C? All right. Part D, we want to find the total distance traveled. So that should be the integral of your speed. So the integral of the magnitude of the velocity vector from 0 to 3. So 0 to 3, square root of dx dt, which I believe was 4t plus 1 squared. And then we had sine of t squared, so sine squared t squared dt. And that came out to be 21.091. And a point here and a point there. Any questions on any of those three? All right, spectacular. Let's see here. This was the next one, but this one is pretty much exactly the same. So we're not going to go through this entire problem. The only piece of this, I mean, we got an equation for the line tangent, so we have to write it in point slope form with the point that we're given. For the point we find in t equals 1. Speed, acceleration vectors, we've been doing that. How do we find the values at which the line tangent to the path of the particle is vertical? We're not going to do this whole thing. It's just how would we do part A here? If we want the tangent to the path of the particle to be vertical, that means that the slope is undefined, right? Right, which means that dx dt needs to equal 0, right? Because dy dx is dy dt over dx dt. So if we want to be vertical, dx dt has to be equal to 0. So we just see when that's equal to 0 on that interval. Everybody good there? Okay. So if you want to work through that one on your own, you can, but otherwise that one's pretty similar to what we've just been doing. Let's see here. I wanted to get to something a little different. Although most of these are all calculator and pretty much the same. Let's see, this has got when is the tangent horizontal, so we'd be setting dy dt equal to 0. You guys want to do this one or no? Or find another one that's a little different? Sure. All right, let's do this one. Why not? This will be the one we do. First couple parts are the same. Part D is a little different. So let's do this one. I'll give you guys 15 minutes to work through this one. We will quickly talk through it, and then we will do the series retake for anybody who needs to do it. All right. In fact, I'm going to give you a little less than 15 minutes. Give you like 12 minutes. And then we'll go through this one because the first couple parts should be really quick. All right, ready, go. Time has started. Part A just wants us to find the speed. We've done the speed a bunch of times. We're looking for the speed at t equals 3. In this case, though, we need to actually, since we're not given dx dt, we have to find dx dt. So what's dx dt? Dx dt ought to be 2t minus 4. So for part A, we're looking at a speed, which is the square root of 2t minus 4 squared plus t e to the t minus 3 minus 1 squared, all evaluated at t equals 3. And you should have got 2.828 for that. This one they gave you a bunch of units. It doesn't specify you need to put units, but meters per second would be the right units there. Just 1 point for that one. Good there, everybody? Part B, the total distance traveled by the particle from 0 to 4. Now total distance ought to be the integral from 0 to 4 of this same exact thing that we just had there. Square root of 2t minus 4 squared plus t e to the t minus 3 minus 1 squared dt. And evaluated from 0 to 4, that comes out to be 11.587. And that one was 2 points, one here and one here. Everyone good with part B? Part C is where things were slightly different from the ones we've done before. First off, we're talking about a time between t equals 0 and t equals 4 where the tangent to the path is horizontal. So that means that dy dx has to equal 0. Right? So we're looking for when does dy dx equals 0, which would be when does dy dt equals 0. And one important thing to keep in mind here is that we cannot let this equal 0 at the same value. So if we plug in our dy dt, which was it te to the t minus 3 minus 1, is that right? I think that was right. Te to the t minus 3 minus 1, yeah. dy dt, set that equal to 0, and you end up getting a value of 2.20794. And you'd be careful just to make sure that it didn't make dx dt equal to 0. I didn't mention that in the last one when we were looking at when is the tangent line or the slope vertical. And make sure that whatever value of t that you get doesn't make the other component's derivative also equal 0. Which is not a problem with this one. So that's that. And then the second part of part C asked us, is the particle moving toward the right or to the left at this point? And so to figure out if it's moving to the right or to the left, we just need to figure out if dx dt, the x component of our particle's motion at t equals 2.20794 is positive or negative. And the value of that is positive. So it's moving to the right. Everybody good with that? And that was worth 3 total points. 1 point for setting dy dt equal to 0, 1 point for this value, and 1 point for moving right with a reasoning that dx dt was positive at that value. Any questions there on part C? And lastly, part D had 3 little parts to it. We said there's a point with x coordinate 5 through which the particle passes twice. Find the following, the 2 values of t where that occurs. So if the x coordinate is 5, we just need to set x of t equal to 5. So part D, we got t squared minus 4t plus 8. Plus 8 equals 5. So t squared minus 4t plus 3 equals 0. T minus 3, t minus 1. Looks like those 2 t values are t equals 1 and t equals 3. So you got 1 point for getting those. And then second thing it asked you, I believe, was what the slopes of the lines were. The slope of the line tangent to it at those points were at t equals 1 and t equals 3. So you're just looking for dy dx at t equals 1 and dy dx at t equals 3, which is just, once again, dy dt over dx dt at 1 and dy dt over dx dt at 3. And so this one came out to be 0.432, and this one came out to be 1. And you got 1 point if you got both of those slopes correct. And then lastly, what did it ask? The y coordinate of that point. So we're going to try and find the y coordinate of that point if we know that y of 2 is 3 plus 1 over e. So we just need to find the displacement from t equals 2 to t equals 3, or from t equals 2 to t equals 1, and then add this initial condition to it. So we'll just do the integral from 2 to 3 of what was our dy dt? It was the te to the t minus 3, I think, minus 1. And then we'll have to add to that our initial, that's 3 plus 1 over e. We'll have to add 3 plus 1 over e to that. And get some number, which according to the scoring guide says that it comes out to be a y coordinate of 4. So that's one more point. Any questions there on part D or any of that in general?